Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Today, we are taking a topic under physics, and the topic is related to electricity. The particular aspect of the electricity we are taking is on the application of the Coulomb's law concerning forces between a set of charges. Now, look at this scenario. Let's say we have two electrical charges, call it Q1, and another electrical charges at another point, call it charge Q2. Now, let's say these two charges, they are separated by distance r. According to Coulomb law, the Coulomb law says that the force of attraction or repulsion between these two point charges is directly proportional to their product, that is Q1, Q2, and inversely proportional to the square of their separation, that is r square. Now, if I remove this proportionality sign, I have the electrical constant K, that is Q1, Q2 divided by r square. This electrical constant K is expressed as 1 all over 4 pi E naught, where E naught, this epsilon E naught, is called permittivity of free space. This particular value of K is equal to this, and this K2 is expressed numerically as 9 times 10 raised to power 9 Newton meter square per Coulomb square. So this is the value for the K. So in a nutshell, the force of attraction or repulsion between charges Q1 and Q2 can be written as F is equal to 1 all over 4 pi E naught, then times Q1, Q2, then divided by r square. Or we can also write it as 9 times 10 raised to power 9 times product of the two charges divided by r square. So this particular expression is the force of attraction or repulsion between 2 point charges. Now, we are going to use this particular formula in solving exercise here. Look at this exercise. Application of Coulomb's law exercise. Three charges Q1, which is plus 4 times 10 raised by minus 9 coulomb, Q2 minus 6 times 10 raised by minus 9 coulomb, and Q3 minus 8 times 10 raised by minus 9 coulomb, are located as shown below. This is Q1, this is Q2, and this is Q3. The question says we should determine the magnitude and direction of the total electric force on charge Q3 due to the influence of the combined effect of charges Q1 and Q2. So what the question is saying is that this particular charge Q3, we want to know the resultant force F that is acting on charge Q3. How do we do that? This is what we are going to do. To find the resultant force F acting on charge Q3, we take charge Q3 as the origin of the Cartesian coordinate system. So this is a charge Q3 as the origin. So we have the x-axis and we have the y-axis. So the y-axis is the vertical axis and the x-axis is the horizontal axis. Now, I want to determine what will be the force Q1 on Q3. Because the charge Q3 is negative and charge Q1 is positive, they are unlike charges. According to the law of electrostatic law, like charges they will repel. These like charges they will repel, unlike charges will attract. So in a nutshell, this Q3 will be attracted by Q1. So this Q3 will be attracted by charge Q1. So that means the effect of charge Q1 on Q3, the force F of charge Q1 on Q3, the force of attraction that will occur, I will take it as 1 subscript 1,3. That is the force of charge Q1 on charge Q3. It will move in this direction. So this angle here, this 37, I can write it here, 37 degree. Now, we want to consider the force that this charge Q3 we experience due to the presence of charge Q2. If you look at the charges, this is negative and this is another negative charge, so there will be a repulsion. That means this charge Q3 will be repelled in this direction. So that means this charge Q3 will be moved in this direction. So I have a force on charge Q3 now due to charge Q2 will be F23. So it will move along this particular direction of the x axis. Now, we want to find the resultant. How do we do that? We know that this charge F13 has a component along the vertical and along the horizontal. So the component of the force of charge Q1 on charge Q3 will be this place for the vertical is going to be F13 sine theta. For the horizontal, it's going to be minus F13 cos theta. So how do we do that? Recall, if you want to resolve a vector along the vertical and horizontal components, let's say this is at angle theta degree and this is the x-axis, and you have vector v here. So this particular vector v, the magnitude of this vector v can be resolved along the x-axis as v cos theta. Along the y-axis will be v sine theta. So that's the idea of what I use in determining the component of force subscript 1,3 along the horizontal and the vertical axis. Now, the question is, how do we now get the value for the force of attraction due to charge Q1 on Q3, which is F13? According to the Coulomb's law that I have here, I've given the formula as F is equal to this now. So that means F subscript 1,3, which is the force of attraction of Q1 on charge Q3, will be this 9 times 10 raised to power 9 times the value of the charges between Q1 and Q3. That is Q1 times Q3 divided by the distance between them. Now, the charge Q1 is 4. So I have 9 times 10 raised to power 9. So Q1 is 4 times 10 raised to power minus 9. 4 times 10 raised to power minus 9. Then times Q3 is 8 times 10 raised to power minus 9. That is 8 times 10 raised to power minus 9. Then divided by the distance between the two charges, that is distance between these two charges. That's what I want to find. Now the distance here is 10 centimeter. You know that 10 centi means 1 over 100. It means 10 centimeter is same thing as 10 times 1 over 100 meter, which is the same thing as 0.1 meter. So the distance between these two charges Q1 and Q3 in meter is 0.1 meter. So I put it this way as 0.1. Then you will square it. So let's use our calculator to evaluate this particular charge, the force of due to charge Q1 on charge Q3. So so the value is 2.88 times 10 raised to power minus 5 Newton. So that's the value of this particular force that I have here. Now, the force F23 that I have here using the same Coulomb's formula that we have here is going to be 9 times 10 raised to power 9, which is the constant. So that means times the distance, the product of these two charges that we have here. That's times 6 times 10 raised to power minus 9, then times this other charge. That's 8 times 10 raised to power minus 9 divided by the distance between them is 8 centimeter. And this 8 centimeter, this particular 8 centimeter, I can convert it to meter as 8 times. This centi means 1 over 100 meter. So this becomes 0.08 meter. So here now, the distance of separation between these two charges, which is 8 centimeter, is 0.08 0.08 meter. So I can write as 0.08 meter, then we square it. And then pressing the calculator, 9 times 10 raised to 9 times 30, so that's a 6.75. 6.75 times 10 raised to minus 5 Newton. So I've gotten the value for these two forces that I have here. Now I want to evaluate this particular component of force F13 along the vertical and along the horizontal. So for this first one, along the vertical, I will write it as Fy is equal to F subscript 13 sine theta, and this theta is 37 degree, and F13 is what we have here, which is 2.88. So I have 2.88 times 10 raised to minus 5 sine 37 degree. So by pressing our calculator, let me see what we are going to get. Times this times that's we are going to have 1.73 times 10 raised to 5. 1.73 times 10 raised to 5 times 10 raised to minus 5 Newton. So that's the components of this force of charge 1 on charge 3. That's the component of this force due to charge 1 on charge 3. So that's the y component, the vertical component. Then the horizontal component of this particular force is going to be F minus Fx, which is a minus F13 subscript 3 cos the angle 37 degree. So this particular force F13 is what we have here, 2.88 times 10 raised to minus 5, then cos that 37 degree. Now if we press our calculator we are going to have something like 2.3 times 10 raised to times 10 raised to minus 5. That's a minus 2.3 times 10 raised to minus 5 Newton. Now if you look at this horizontal x-axis, this particular force is in the negative direction and this particular force is in the positive direction. So the resultant force along the x-axis will be the addition of these two. That is F subscript 23 minus F1 subscript 3 cos theta. And the F subscript 23 is what we have here. That's a 6.75 times 10 raised to minus 5 Newton. Then minus F subscript 13 cos theta is what we have here. That's a 2.3 times 10 raised to minus 5 Newton. And this particular resultant along the x-axis, pressing the calculator, let me see, we give us 4.45 times 10 raised to minus 5 Newton. So now that I've resolved this along the vertical and along the horizontal, what I'm going to have left now will be something like this, F13 sine theta. And then what I have here along the x-axis is 4.45 times 10 raised to minus 5. This particular vertical value of the force F13 sine theta is what we have here, which is 1.73 times 10 raised to minus 5 Newton. So to find the resultant, if this force is moving in this direction and this force is moving in this direction, we can resolve the resultant. How do we find the resultant? When I move in this direction, due to this diagram I have here, I can equally move in this direction due to this force moving in this direction. So the resultant will now be starting from the same origin here to this place at an angle theta. So the vertical side of this force, which is this 1.73 times 10 raised to minus 5 Newton. The horizontal side of it is 4.45 times 10 raised to minus 5 Newton. So because we have a right angle triangle, using the Pythagoras theorem, R will be square root of the vertical squared, 1.7 times 10 raised power minus 5 Newton. We square it, plus the horizontal square, that's a 4.45 times 10 raised power minus 5 squared. So by pressing the calculator, our resultant force now is 4.47 times 10 raised power minus 5 Newton. This particular resultant force I have is the force that will be acting on charge Q3 due to the presence of charge Q1 and Q2. Now, how do you find this direction? Theta. We can have tan theta. Tan theta is opposite divided by adjacent. And the opposite in this triangle is 1.73 times 10 raised power minus 5 over adjacent. The adjacent is 4.45 times 10 raised power minus 5. 4.45 times 10 raised power minus 5. So that's our tan theta. To find theta, we find the tan arc. Tan arc of this value that we have here. You press tan arc in your calculator. So let me press, okay. Tan arc of 1.73 times 10 raised power minus 5 divided by 4.45 times 10 raised power minus 5. We have theta degree to be 21 degree. So that means the angle theta that we have here is actually 21 degree. Now, if you take this place as the north and this place as the south, we can find the value of this theta by subtracting 23 from 90. So when you subtract 23 from 90, I'm having 67 degree. So that means the direction of this particular resultant is going to be north 67 degree east. So the direction of the force R is given as 4.47 times 10 raised power minus 5, then comma north 67 degree east. This one gives us the direction, this one gives us the magnitude. So we have gotten both the magnitude and the direction of the force acting on the point charge Q3. I believe that you must have learned one or two things in the presentation of the solution of the force, the electrostatic force acting on a given charge due to the presence of other charges. Thank you for having your time, and please do not forget to like, share, subscribe, and click on the notification button to have more of my video. Have a nice day. Bye.